So this is Terraform deployments, no passwords allowed. So we're going to be talking about OpenID Connect, which is a new sort of technology around authenticating to cloud providers in order that you don't have to use any passwords, which is passwords are a huge security risk when it comes to basically bigger corporations, right? When you get a password gets let loose and that account may have lots of access, that's a huge risk to security. So that's mainly why this is useful. Before I go any further, I want to ask how many of you guys know what Terraform is or infrastructure as code? Like, raise of hands if you're like familiar enough to know what those words mean. Okay, a couple. So I'll start off with first talking about what Terraform is. And so if we take another step back, how many of you guys know how the cloud works? Like, let's say Azure, if you're familiar with that. Show by a raise of hands. Okay. Take another step back. Okay, so so the cloud, right, is it's infrastructure. Okay, the cloud is where you can through the portal or through code you can deploy resources like a virtual machine, etc. So typically you would do that through your portal, your UI, you flick and point, and you can deploy a VM or whatnot. So it's kind of elevated past that though, where corporations and bigger companies may want to automatically deploy things. So let's say, I want to deploy VMs on demand when they're needed, or things like that. So that's where infrastructure as code comes in, where you can codify when you want things deployed and in what order and how they're secured, and all these sort of different facets about that, so that you can deploy real resources out into the world and then have them up and running and usable for your company by just writing some code and automating it. So Terraform is the coding portion where you might code the things you want to create out there. So a virtual machine, a key vault, a database, whatever. And then the automation part. So the automation can be done with like Azure pipelines or like GitHub Actions. Today we're going to be focusing on GitHub Actions to do that portion of it. So the stuff, aka the thing that says, hey, run the Terraform, create the thing. And when that gets called, it says, okay, I'm going to start my job and go ahead and run that Terraform and stand up whatever resources you talk about. So OpenID Connect is, it's a authentication and authorization mechanism that you use from your pipeline or your automation that basically gives it authorization to go create those resources out there, right? It needs to have credentials. It needs to be able to access, let's say, those resources that are really sensitive and you don't want to be torn down on accident. So the OpenID Connect enables that authorization and authentication without using a password, that's what we're talking about, why it's a big deal. Okay, does that all make sense so far? Cool. Okay, so OpenID Connect, which is abbreviated as OIDC, is that authentication we talked about. Yeah, I think I already covered that. So in this demonstration, we're going to be talking about Azure with this. You can do this also with AWS or other providers. It's kind of a new thing, so different cloud providers are starting to pick this up and make it more of a priority because it is kind of a cool new feature. Okay. Yeah, go ahead.
The sliders.
Yeah.
The advantage to not using a long-lived secret to do like my...
Oh, yeah. So one of it's like the password isn't out there, so you're not risking that it gets exposed and someone can use it for malicious purposes. The second reason is a lot of these service principals have passwords that get rotated every 6 months or a year. So you have to keep maintaining those passwords and keep updating them. So if you have that password saved in your automation pipeline and as a secret or whatever, you got to go send a reminder to your IT department that you need to go fix this password and put the new one in there now so that things don't just randomly start breaking when it's continuously deployed. What's the advantage of removing passwords from being needed in deployments or with your Terraform? Azure, we talked about, is the cloud provider that we're going with today for this demonstration. So let's go back here. So if you go into Azure Active Directory, this is where you manage your users and your accounts. We have things called service principals, or in our case, they're called app registrations. So it's kind of one and the same, this sort of term. but it's a name for a service account. So it's not tied to any person like you or I. It's an account that has an ID and a password. And these are the ones we're talking about that you need to rotate them because they often have really high amounts of privilege. So you don't want that access getting out there. So this one here, this is the one we're using for demonstration purposes. This is the app registration or service principal. And we have we have certificates and secrets. So this is where, in order to do this is the backend setup in order to do the OpenID Connect authentication when you are doing a deployment. So I'll just show you guys this briefly, but basically the step in here is you need to create a credential, a federated credential. And so I'll just show you this one that we already have created. And you're basically giving it authorization to detect deployments from a particular source. So in this case, you see GitHub Actions deploying Azure resources. So that's saying, if GitHub tries to deploy something from this particular repo and environment, then you get to let it go through without a password because it's already got the right authentication authority, basically. You're pre-authorizing it is one way you can think about it. So we're going to go here. So we're going to start doing a GitHub Actions workflow run. So this is the automation portion that we talked about. So I'll go here to, this is the name of this workflow, and it's Azure Terraform deploy with OIDC. We're going to just hit run on this. And then we're going to watch it run, and then we'll see what happens. So first I'll take a look at the actual file that we're running. So this is the top level, what's going to be happening or what's going to be executed. You guys can see that okay. So workflows and automation in general, typically they're built up in jobs and then steps. So we're just using, So we have a job here. I'm going to kind of make this as simple as possible without getting into too many of the weeds, but right here, this step says log into Azure, and you can see that we're providing some information, but there's no secret provided here. So this is secretless, in other words. We still have a couple secrets here that are saved, but these are non-sensitive. So client ID is like a username, basically. Tenant ID is, this is just referring to where in Azure it needs to be connected. So this login happens, and then we get some code, and then we do a Terraform init plan and apply, which basically the init and the plan are the initialization and saying what we're going to do next. Then the apply says, go deploy this infrastructure out. So in our case, I'm just creating a resource group and putting some resources in it for proof of concept. So yeah, that's this file. Let's go back and see where our run is at.
Did you have to add Terraform CLI to your action? Do you have to use it that?
Yeah, like Terraform had to be installed on the agent in order so that, like Terraform CLI, right? That in order to run the init, the plan, and the apply, you have to have Terraform installed.
Was that a step?
I think it was already on the agent. Like it was pre-installed.
Did it on Remit?
I think it's one of the GitHub ones. I think they just have it on there. They have, there's a list online somewhere of all the pre-installed pieces of software and stuff. Okay, so let's see where we are in this process. Okay, so we got our login. And see, it says federated token details. So when you request authentication, returns a token, and then that gives it authority to go ahead and do other things in the cloud. So now we have our Terraform executing. You can see it's creating some objects. So we got a key vault here and a SQL server. And so we'll see those in a minute when this gets done. So I've been talking so far. I haven't showed you any actual Terraform, and just because I don't want to overwhelm you guys with too much all right in the beginning. So we'll go see these out there, and then I'll show you kind of the Terraform that actually gets executed as part of it, because the pipeline's that front end. Basically, you can think about it, that's making those calls to say, okay, go deploy these things, but then you have to describe what in the Terraform, what you're actually going to be deploying. So, and that could be a whole talk on its own. So like just how Terraform works and everything. So Obviously, feel free to ask questions about that, but I'm not expecting you guys all to know how everything all works by the end of this because there's a lot to cover in that. So,
with the backend headed Active Directory, where do you have to get action?
it is. Mm-hmm. Yeah. Yeah, so you have to create a app registration, and then in that app registration, you give it permission to use this federated. You create a federated credential on top of it, just like you would a secret. So instead of creating a secret that you now need to rotate, you just create a federated credential that allows it to connect, and it is out of the box. The question was, is this capability out of the box?
And for those of us who don't know, what's a federated credential?
It's a fancy name for giving it a new, like, I don't know how to describe it in words. It basically is just giving it the connection so that when GitHub calls it, the federated credential, it goes and finds the federated credential and checks it and says, yeah, this one matches. And so part of it is that if we look at this federated credential, it has to match the org that it's coming out of, the repo, and then the environment. So in this case, I put a production environment here, so that if I try and deploy to dev or test or whatever, it's gonna fail to get this credential back. So that's
Selection of information versus just like a...
Yeah. It's the way that GitHub talks to Azure and says, do I have access to this? If I provide these without the secret, the client ID, tenant ID, subscription ID, says, can I access these things? Can I log in? And Azure says, yeah, you're coming from the production environment in a GitHub repo that we already know about. So yeah, here's your token back, which gives you your authorization. Yeah, it's exchanging trust so that you can go do further things.
Issuer there, that's something that GitHub provides that did you create the URL?
So that's built in. So you can change this federated credential scenario. So there's other scenarios where you can use this OpenID Connect model, but in this case, we're showing off the GitHub version of it. So there's other ways you can use this.
And that URL would only work point from GitHub.
Yeah.
If you were trying to use it somewhere else, it would.
Yeah, exactly. But you can do like a custom or like another issuer. And so I'm sure there are other ways to use this same functionality from not GitHub, but you got to go through those steps.
So that means all users, I guess.
It's connected to the, because this is attached to the app registration. So think of it like an account, but it's not attached to any particular user like you or me or whoever. So this is like does that make sense? Yeah, so it's only meant for automation. Yeah, and connecting up between like a workflow that might run automatically, that it's connected over to the credential so that it can actually do its job and whatever that means. Okay, so this completed. So now let's take a look at these resources. So this is our resource group that we just created. So it's called TestRG. We have some key vaults in here, a SQL server, and these are all, and a database that's connected. So these are all ready to use and ready to run. So this is just a sample of, okay, you can deploy some things out there and go through this process, and we didn't have to use any passwords for it. So at this point, I'll show you guys kind of how the Terraform piece works. Do you guys have any questions as of now? Okay, cool. Okay, so when I did that Terraform init, plan and apply, that's what you guys saw, and that's what actually went and did all the creation of those resources. So this file is the one that I pulled in and said, okay, use this directory, and there's only one file in this directory, and execute it. So you'll see here we have, there's some setup here, so I'll touch back on this in a second. And then we have modules here, which you can think of like a class per se. And so this class defines what we want our resource group to look like. So the source of it is a module. Well, this is actually a reference to a particular commit inside of a repository. But it's saying, grab this particular piece of code and run this piece of code with the name test.rg, and the piece of code declares what a resource group would look like. So we can take a look at that just for sample sake. So this is what this is the module of a resource group. So we called the word module, we referenced this location. This location contains the declarative code for what this resource group is going to look like. So it's very simple, but it's just got a name, a location, and any kind of tagging that you want to put on it. So it could be business unit XYZ or whatnot. So this is the general sense of how a module works, is that you call it and it says, okay, I'll go grab that code and deploy it as you have specified. And that can be variabilized and all those sorts of things. Okay, so if we go back here, you see we have the same pattern. We have a resource group, a key vault, a SQL server, and a database, and these are all the things that we saw out there. And they're kind of built in that same sort of way. Okay, so now we'll go into the setup that makes the OIDC possible when you deploy from GitHub Actions. So first of all, we're using what we call the Azure M provider. So this is the Azure M provider belongs to HashiCorp, creator of Terraform, but this provider contains the details on how when you use these resources, for example, in here, this resource, Azure M resource group, this is predefined by HashiCorp of what that looks like. And on their end is where they go from, we write some declarative code and it transitions to basically an API call in the back end to tell Azure, hey, build this resource. So that's what the provider is. There are versions of those, obviously, because as Azure changes and new resources come out and new features are released, there's new things that need to be added to the Terraform language as well, and particularly the Azure M provider. Okay, so we'll go back here. So this is the provider Azure M. We have this flag here that says use OIDC, and this is what determines that we're going to be using the OIDC authentication that we already had established in the pipeline or in the workflow. So we already did our authentication. Now we're telling it use this OIDC method, and because it's running out of GitHub Actions, it can connect those two dots and say, okay, we can make this deployment happen without having to use the password and everything, because when Terraform runs, it actually re-authenticates, make sure that you are providing the correct information. So you could instead provide a username and password for an individual, or a service principal where you'd provide client ID, client secret. Client secret's the password that we're trying to omit here, so that we can remove that security risk. Okay. This features block is kind of a standard thing that we just define when we're defining our provider. The other bit with this is that we have Terraform, and then we define our backend, this is where the state is held. And the state is a record of what's already out there. So when Terraform deploys something like that resource group, it'll keep a record of, okay, I deployed this resource group and these resources, and they should look like this and have this configuration. So when you go ahead and redeploy, again, it's going to go check that state matches what's already out there, and if something got destroyed or torn down, it re-updates that resource according to the state file of what it should look like. So this is this Terraform backend of Azure M is a reference to where the state is actually being held, because the state file can be held locally, but when you're doing deployments out of workflows, you always want it to be somewhere that everyone can access it, right? So if it's you or me, or if it's being run on one kind of VM or another VM, that it's easily accessible from all sides. Yeah, go ahead.
Hey, on line 32, I think, where you have a source, and it looks like it's to one of the files they have in this repo, where that went, like on GitHub.
Yep.
what would happen if you had a private repo, or maybe this is a private repo, like does it, because it's running in a GitHub action, does it just automatically have access to that file, or?
That's a good question, actually. So, well, what happens is, I'm pretty sure it has to be, the question was, this module is referencing a GitHub repo out in GitHub. So do you need to have access in order to grab these modules? And I believe you have to have, I believe it has to be public, where it can be publicly accessible, and this one is.
Can you do a local path, like if this is just like another file, instead of like doing the hub.com path, just do like ./ whatever?
Yep. So then in that case, you do, I have a sample here. So for SQL Server, you just do a local path. So this just goes up a couple directories into the modules folder and then into the SQL Server.
Custom module, I guess, in a private repo. Just reference it later, and that will work. Okay.
Yeah, of course. Yeah. Does anyone have any other questions about like Terraform in general, or I know I kind of gave you guys a lot of information to process.
I was wondering if you had any thought Terraform first, like Bicep and.
Yeah. So ARM templates are, it's kind of pick your flavor, right? When you have ARM templates and Bicep templates, I think Bicep is, isn't that Azure's new thing, or is it cross-platform?
I think it's a subset of ARM based.
Yeah, so the advantage with Terraform is that, like we talked about, the Azure RM provider that's maintained, well, there are providers for AWS, for like all sorts of different services that these providers exist. So once you learn Terraform, you know how to use it for various other services that you might need in the cloud. So the different providers, but you can also use it in other scenarios, like basically like you can even secure your GitHub enterprise by using Terraform and say, I want these branch policies in place and I want these protections in place so that people can't make changes to code. So my 2 cents is that the Terraform has been up and coming the last 5 or so years, in that you can use it across different purposes, where as opposed to ARM or Bicep, where you're kind of stuck with you're with your one cloud. So it has more cross functionality, I guess.
Could you, how generic is Terraform? So could you just point this at, run, or is it actually kind of?
Oh yeah, so Terraform has a ton of different providers. So you can see AWS, Google Cloud, Kubernetes is a big one. So for clusters and things like that, you can actually do your Azure Active Directory on it. So deploying service principals and things of that nature. So it's very cross functional across different workspaces.
Would you have to choose the file for your Terraform?
Oh, yeah. So you'd have to say, I want the AWS provider. You'd have to declare that provider. You'd have to authenticate, right? So instead of like how we did with OIDC, you'd have to do something similar and do the same, where you provide like a username and password or whatever to authenticate that provider, and then start deploying your resources. Does that make sense? You would just use a different provider, and there's, yep. And they have the same concept of service principals, etc. It may not be called the same thing, but service accounts instead of user accounts in AWS and GCP. So,
do you have to use like a Terraform language to do Terraform? Can I write Terraform?
yeah,
It's sort of my follow-up question.
Yes. Well, so more specifically, the Terraform language is like, it's called HashiCorp Configuration Language, HCL. And yeah, you have to use that. It's, it's a declaration of the resources you want. So like here in, let's see, a storage account. So you have all these, for a storage account in Azure, you have all these different options. So one of the advantages is you can hard code some of these. So if you're in an organization that you can hard code almost all of them except maybe the name. So they all have the same security. And then as an organization, when you deploy a storage account, they're all deployed the same way. And when you maintain that state file that we talked about, or that record of what's already previously been deployed, and you redeploy the same infrastructure, it's going to go check that state file and say, is anything missing? Do I need to repair anything? Were any security settings changed? That it might need to update. So yeah.
And when it comes to providers, the Azure provider is already part of a STEMI subscription. Most approaches.
The Azure M provider. So that Azure M provider is part of HashiCorp, who owns Terraform. They produce the Azure M provider and are constantly updating it. It's actually on GitHub, so you can see all the code that's out there. It's all public, but they're constantly revving it, and it belongs to HashiCorp.
To actually install it for Azure subscription.
So you would install it. So basically, here I can.
Box or.
So when you do your, I kind of skipped around on this a little bit, but when you do a Terraform init, so when you are so now I just navigated into this folder that has the main file that we've been looking at, and this is what controlled that whole deployment. When you do a Terraform init, it will download those files, or it'll download the Azure M provider based on how you declare it. So when you declare it and you have a particular version, so you can see required providers, Azure M, this version number, it's going to go install that, or not install, but download it locally so that it has it to then go do that stuff. So the answer to your question is that it's not in Azure. You don't have to do any installation in Azure. You just need to set up the credential system with, a service principal that can have permissions and access to go ahead and deploy those resources. And this is just the method on a local side where you can tell Azure. So instead of having a REST API or ARM or Bicep, Terraform's a different tool that you can use to have the same outcome, but also have that maintenance of your structure.
Turning in.
Oh, yeah.
When you download that provider, is it like downloading, added a CLI tool behind the scenes to be able to, like if you run the Terraform apply, it actually goes and makes those changes, or starts making those changes with your local machine, it is using like its downloaded version of the Azure CLI or AWS CLI or whatever, like is that just included with the provider, or do you have to like install the AWS CLI to use the AWS provider?
So you don't need like the AWS CLI, let's say. Well, you need to install the Terraform CLI. And then once you have Terraform and you define, okay, we need the AWS provider right here, and you specify a version. If you do a Terraform init, it's going to download that provider, and that provider contains the resources that you might define. Like in our case of Azure, it was like Key Vault. So it's downloading those definitions of how it's going to go ahead and do the execution when and if you need to call those pieces of it, if that makes sense.
How is it translating those into, like, is your local machine like actually sending out like API calls to AWS? Like how are they trained?
Yeah.
From Terraform into
So you do
actual calls.
Yeah, so the Terraform init does the download portion. You do a Terraform plan, which plans out, okay, looking at the infrastructure that's out there. Okay, we have a blank state file. We need to just deploy these things. It'll plan, say, okay, we need to add this resource and this resource. And then when you do the apply, it'll go ahead and make those calls, which is what the Terraform, when the version of Terraform, it handles those.
So Terraform's
Well, it's Terraform is like the baseline tool, and then the provider is on top of it. So I guess I should clarify that the Azure M provider or the AWS provider is going to handle how to make those API calls. So when a new feature gets added, they rev the AWS provider. So now when you have your Terraform, you can call and add this new feature into your cloud provider by tweaking some parameters that it previously would not have had available on an older version of that AWS provider.
That's fake.
Yeah.
And in general, the Terraform service purely strictly resource-specific passwordless authentication that can be used for individual user logins.
You can use individual users, so you can do like if you have the Azure CLI in this case, you can do an AZ login with your personal account and then start running Terraform, and it'll auto authenticate with your account basically, so that you can make those calls out to those resource groups or those locations out in the cloud.
For all your application users, they do it just roll the same way.
Yeah, you could do it with all your application users. The thing is that you have to have the authorization as well. So if I don't have access to touch a particular subscription or however it's segmented in your cloud provider, then I can't make any changes there. So I would personally have to be able to, basically, if I can do it in the portal, I can click around and make those changes, then I can do it from Terraform or on my local machine by using this tool.
Basically, the applications that put in battle.
Yeah, so if you wanted a user to make changes to Azure, they need to have access to Azure. Or oftentimes the way they secure that is instead of using a user account, use the service principals. And so you would locally have the client ID, client secret, and you could use those instead of your personal account. You would use these credentials to go ahead and make those changes.
But if there is no need for users to do anything in the Azure host, well, just to log into the application, is it still possible?
So Terraform is about changing infrastructure. So like your virtual machine or your database or whatever, you want to tear it down, you want to build it back up. So if you don't want your users doing those things, like changing actual resources in the cloud, then you wouldn't want them to have access to make modifications, right? You can give them read access. Let's say you give them an account and they have read access to these resources, but if you don't want them deleting things, you wouldn't give them those privileges. And so they wouldn't be able to do it with Terraform either. Does that make sense?
So basically, they're talking about passwords of implementation for an application that is not really, has nothing to do with changing infrastructure and also some other methods.
Yeah, because if you're authenticating to an application, that's separate from authenticating to the cloud provider to change infrastructure.
One last question.
Yeah.
Is to try and do entity framework migrations in Terraform, or was that something that Terraform's just, that's not like infrastructure, but it's like making stand up my database that and be able to like run migrations or something like that, or we will do the best that makes sense for Terraform.
I would probably use like Apache Spark or something else like that, like a different tool. I'm not aware of the usage of that with databases and Terraform. Terraform's about setting up those databases, not like, okay, modify the data inside of it, because it doesn't touch the data on the inside. Anyone else have any questions, cloud related? Oh, cool. That's all I got. Okay. Thank you.
Will you pull up your other blog thing? It's for an overview of tech.
Yeah. Here, I can, yeah, for sure. This was kind of a top-down level where I know it's probably a bit confusing. So this is on our website. We have several different Terraform articles. This one's by Kevin Bost. And this is kind of how to get started and learn how to basically just get started with Terraform and do some simplistic things. I also wrote a blog on the upper end of that, which is kind of organizing your Terraform directories as a better structure so you can separate your deployments and deploy things in a secure way where it's more layered. So that's more like if you have an enterprise and you want to deploy all your networking together and you want all, where you're deploying across your organization instead of just one or two individual resources.
Get IntelliSense in VS Code review, download a provider, like auto-complete suggestions for when you're configuring like Azure data.
I think it's just the Terraform extension, but it does.
Or does that extension? No.
Yeah, it does some autocomplete stuff. It's less advanced than like IntelliSense or other things. It's not predictive and like, oh, you might need this property or that property. It's more like you can hit tab and it'll fill it in for you. But they do have an Azure Terraform extension. So would be more related to all the Azure resources.
So I'll just need like an extension per like cloud provider.
Mm-hmm. And typically you're, using one or two. So yeah. Cool. Well, I'll let you guys mingle and hang out. So we have some extra time.